My name is Hridik. Welcome to my channel Aspire Coder. Prepare to witness the magic of container orchestration and unlock the potential of your applications. Remember, the days of managing applications like untangling spaghetti, struggling with server sprawl and manual deployments, those days are gone. Welcome to the world of Kubernetes, where your application runs smoothly, efficiently, and in perfect harmony, just like a well-planned city. Kubernetes is an open source system to deploy, scale, and manage containerized applications anywhere. Kubernetes automates operational tasks of container management. With Kubernetes, you can deploy applications, make changes to them, scale them up or down depending on your needs, and monitor them. All these features make it easy to manage your applications. Kubernetes was launched by Google in 2014. Its name comes from the Greek word meaning handsman or pilot, and the abbreviation K8 results from counting the 8 letters between the K and the S. Kubernetes combines Google's 15 years of experience running production workloads with best practices from the community. There were three different eras: traditional deployment era, virtualized deployment era, container deployment era. In traditional deployment era, applications were often run on a physical server without the ability to define resource boundaries. This often caused issues with resource allocation, where one application could dominate resources, leaving others to underperform. One solution was to run each application on a separate physical server, but this proved to be both costly and inefficient. As organization grew, this approach simply didn't scale. In virtualized deployment era, to address the challenges of managing multiple applications on a single physical server, virtualization was introduced. This technology enables the creation of multiple virtual machines that can each run their own application in isolation from each other, thus enhancing security. Additionally, virtualization allows for more efficient use of server resources, improved scalability, reduced hardware expenses, and much more. Essentially, virtualization enables the presentation of a cluster of virtual machines as a set of physical resources, with each virtual machine functioning as a complete machine, complete with its own operating system, all running on top of virtualized hardware. Then comes the container deployment era. Containers are like virtual machines but are lightweight due to relaxed isolation, sharing the OS among applications. They possess their own file system, CPU, memory, and process space, ensuring portability across various clouds and OS distributions. So, why you need Kubernetes and what it can do? Containers are a good way to bundle and run your applications. In a production environment, you need to manage the containers that run the application and ensure that there is no downtime. For example, if a container goes down, another container needs to start. Wouldn't it be easier if this behavior was handled by a system? That's how Kubernetes come to this rescue. Kubernetes provides you with a framework to run distributed system resiliently. It takes care of scaling and failure for your application, provides deployment patterns and more. For example, Kubernetes can easily manage a canary deployment for your system. Kubernetes provides you with a lot of features like service discovery and load balancing. Kubernetes can expose a container using the DNS name or using their own IP address. If traffic to a container is high, Kubernetes is able to load balance and distribute the traffic so that the deployment is stable. Storage orchestration. Kubernetes allows you to automatically mount a storage system of your choice such as local storages, public cloud providers, and more. Automated rollouts and rollbacks. You can use Kubernetes to easily manage the state of your deployed containers. With Kubernetes, you can specify the desired state of your containers and it will automatically adjust the actual state to match this at a controlled pace. This means that you can let Kubernetes create new containers for your deployment, removing existing containers and transfer all their resources to the new container without any hassle. It's a great way to make sure that your containers are always up to date and running smoothly. Automatic bin packing. You provide Kubernetes with a cluster of nodes that it can use to run containerized tasks. You tell Kubernetes how much CPU and memory each container needs. Kubernetes can fit containers onto your nodes to make best use of your resources. Help scaling. Kubernetes restarts container that fail, replaces container, kills containers that don't respond to your user-defined health check, and doesn't advertise them to clients until they are ready to serve. Secret and configuration management. Kubernetes lets you store and manage sensitive information such as passwords, auth tokens, and SSH keys. You can deploy and update secrets and application configuration without rebuilding your container images and without exposing secrets in your stack configuration. Batch execution. Kubernetes is pretty cool. Not only can it handle your services, but it can also manage your batch and CI workloads. And if any of your containers fail, Kubernetes has got you back by replacing them for you. Horizontal scaling. Scale your application up and down with a simple command with a UI or automatically based on CPU usage. IPv4, IPv6 dual stack. Allocation of IPv4 and IPv6 addresses to ports and services. And it is designed for extensibility. It means that it adds features to your Kubernetes cluster without changing upstream source code. Now we look into the architecture of Kubernetes. A Kubernetes cluster is a powerful system for managing containerized applications. It consists of several key components working together to ensure your applications run smoothly and efficiently. Let's dive into each of them. You can see a master node. Think of these as the brain of the cluster. They manage and control all other components including Kube API server, etcd, Kube scheduler, Kube control manager. What is a Kube API server? This is the central API that accepts requests from other components and interacts with the cluster state. etcd, a highly available key value store that stores the cluster's configuration and state. Kube scheduler, it assigns ports to nodes based on resource availability and scheduling rules. Kube control manager, it runs various controllers that manage different aspects of the cluster like replacing ports and ensuring availability. Looking at the worker nodes, we can see that these are the workhorses of the cluster. They run the actual containerized applications. Each node usually has two components known as kubelet, which communicates with the master nodes to receive instructions and manage ports on the node. A container runtime, which runs the container within the ports, example Docker, CRIO, etc. Kube proxy, it implements the cluster's networking, allowing ports to communicate with each other. So, what are ports? These are the basic units of deployment in Kubernetes. They represent a single application or a group of tightly coupled containers that share resources and storage. Think of them as apartments within a city. Here, cluster is a city. Controllers. These are background processes that manage ports and other resources to maintain the desired state of your application. These processes are responsible for managing things like ports and other resources to make sure everything is in the state that you want to be in. Some of the things they do include deployment. This process helps manage the lifecycle of ports so that they are always working the way you want them to. Replica set. This process ensures that you always have the right number of ports replicas running. Stateful set. This process helps manage ports that need persistent storage and that need to be deployed and terminated in a specific order. Kubernetes creates a virtual network within the cluster, allowing ports to communicate with each other across nodes. This network consists of CNI plugins whose role is to connect the cluster's virtual network to the underlying network infrastructure. Pod IP addresses. Unique IP addresses assigned to each port for internal communications. The services and ingress direct external traffic to applications within the cluster. Storage. Kubernetes makes it easy for your application to store data using something called persistent volumes. These are like external hard drives or cloud storage that your app can use to keep data safe even if the app is stopped or restarted. And if your app needs more storage space, it can simply request it using persistent volume claims. Additional components in a Kubernetes cluster are logging system, monitoring tools like CI/CD pipelines, and security solutions that integrate with a Kubernetes cluster to enhance its functionality and management. By understanding these components and their interactions, you gain a deeper appreciation for the power and complexity of Kubernetes. Remember, it's a flexible and customizable system, allowing you to tailor it to your specific needs and applications. Container orchestration system can be a complex concept to grasp. However, to help you understand how Kubernetes operates, an analogy of a metropolis has been created. This analogy simplifies the working of Kubernetes and makes it easier to comprehend. Let's name this city Kubernetes City, where applications thrive like skyscrapers. Imagine a bustling metropolis, not of steel and concrete, but a vibrant application, each one a towering skyscraper, humming with activity. This is Kubernetes City, a meticulously planned urban landscape where containers, the building blocks of your application, live and work in perfect harmony. The mayor, meet Kube API server, the charismatic mayor who oversees the entire city. Every request, every change, every interaction between applications flows through them, ensuring everything runs smoothly. The city council. Think of controllers as the diligent city council, constantly monitoring and maintaining the city's infrastructure. They ensure ports have the resources they need, respond to the emergencies like crashes, and even build new ports on demand. The neighborhoods. Pods are the self-contained neighborhoods where your applications reside. Each holds its own set of containers like restaurants, shops, and apartments, all working together to serve a specific purpose. The traffic network. Services act as the city's intricate network of roads and bridges, enabling seamless communication between different ports and applications. No matter where they are in the city, they can easily reach each other. The power grid. Persistent volumes are the city's reliable power grid, providing persistent storage for applications that need it, like hospital or data centers. They ensure information is always available, even during unexpected power outages. The construction queues. Deployment is the city's dedicated construction crews. Overseeing the construction and expansion of application neighborhoods, they carefully plan, build, and manage new ports, ensuring a smooth transition for residents. That residents can be considered as containers. The citizen. Finally, you have the individual containers, the hardworking citizen of Kubernetes City. Each plays a specific role, whether it's processing data, serving web pages, or managing resources. Together they make the city thrive. So, what are the benefits of living in Kubernetes City? Its efficiency, scalability, resilience, and collaboration. Application runs smoothly and efficiently without the need for manual configuration or server sprawl. The city can easily expand and adapt, adding new ports and resources as needed to meet growing demands. If a port crashes, it's quickly replaced, ensuring applications stay available and operational. Applications can easily communicate and share resources, fostering a vibrant and interconnected ecosystem. So, if you are tired of application management chaos, welcome to Kubernetes City. Here, your applications can reach new heights, unburdened by complexity and powered by the sophisticated urban planning of this container paradise. This analogy can be further extended by adding details about specific features like network policies, resource quotas, namespaces. Remember, Kubernetes isn't just about deploying containers, it's about empowering developers with faster deployments, higher scalability, and a self-healing application ecosystem. Embrace the future of application development with Kubernetes. Thanks for joining me on this journey into the world of Kubernetes. What are your biggest concerns or questions about Kubernetes? Let's discuss them in the comments. Thank you.